Click the Set button to set up the Melt Temp melting point apparatus. Observe the animations carefully. Which substance melts first? What can you say about the melting points of the substances? A has a very high melting point, whereas B melts at a lower temperature. Which substance do you think is an ionic compound? A is most likely to be an ionic compound compared to B. Do you wonder why an ionic compound has high melting and boiling points? Or why a covalent compound has low melting and boiling points? Let's see the microscopic events when we heat these substances to its melting and boiling points. In this lesson, you will be looking at the melting and boiling points of ionic and covalent compounds. At the end of this lesson, students should be able to describe differences in melting and boiling points of ionic and covalent compounds.
An ionic compound is made up of positive and negative ions. These positive and negative ions attract each other and group together in a giant structure called crystal lattice. In the crystal lattice, each positive ion is surrounded by several negative ions. In turn, each negative ion is surrounded by several positive ions. In order to melt an ionic compound, the forces that hold the ions together must be overcome. Since there is a massive number of ions present in an ionic compound, the overall value of the force between ions is very great. This makes ionic compounds have very high melting points. For example, sodium chloride has a melting point of 800 degrees Celsius. Click Zoom to see the microscopic events when we heat sodium chloride to its melting. As heat is being supplied and absorbed by the ions, they vibrate and move. At first, it moves slowly in all directions. When more energy is being absorbed, the ions move faster and the distance between the ions becomes further apart. This process goes on until all of the substance becomes liquid. At this point, that is the melting point. The forces between the ions are weak. Thus, the ions can now move freely in the liquid state. The covalent bonds inside the molecules are very strong. The molecules do not break apart easily. However, the forces attracting neighboring molecules to each other are very weak. It is therefore very easy to separate molecules from one another. When a covalent compound is melted, it is the forces between the molecules that are broken. These intermolecular forces are generally weak, and so melting points of covalent compounds are low. For example, the melting point of naphthalene is 80 degrees Celsius. Click the zoom button to find out. As heat is being supplied and absorbed by the molecules, they vibrate and move. At first, it moves slowly in all directions, and with small amount of energy, the molecules move further apart. At this point, that is the melting point, the weak forces between the molecules finally break. Thus, the molecules can now move freely in the liquid state. The explanation for the differences in melting and boiling points of ionic and covalent compounds are: when an ionic compound melts or boils, it is the attractive forces between the ions which are broken. A lot of energy is needed to make this happen, so ionic substances have high melting and boiling points. When a covalent compound melts or boils, it is the forces between the molecules which are broken. Very little energy is needed to make this happen, so covalent substances have low melting and boiling points.
In this lesson, you have learned that ionic compounds have high melting and boiling points because a lot of energy is needed to break the strong attractive forces between the ions in their lattice structure. Covalent compounds have low melting and boiling points because very little energy is needed to break the weak forces between their molecules. Diamond is made up of carbon atoms. It is a covalent compound and has a very high melting point. Find out why diamond has such a high melting point. Then, write a report on your findings on why diamond has a very high melting point. Submit the report to your teacher.